Good evening all. Today I'm here to talk about best practice of performance tunings of OpenStack cloud with Ceph. So by the way, how many people are using this OpenStack with Ceph? Wow, good number. I think almost everybody is using it out. Anybody newcomers for the Ceph? Okay, one. Great. So everybody knows about Ceph. Good. Okay, so before going for the next slide, we want to introduce ourselves, who we are. I am Swami Reddy, working with RJL. I am working with OpenStack and Ceph projects for last 3 years. As my job key responsibilities, I need to manage my Ceph clusters, which are backend for OpenStack clouds. I am having around 15 years of open source community experience, like linux.org, gnu.org, gcc.org. So I am familiar with all open source communities across the world. So now let me introduce my colleague, Mr. Pondian, who is a ATC in OpenStack and key contributor for all projects. He's doing a lot of patches and all things, and he's one of the core community member in India OpenStack community. Okay, sorry. Okay, now let's go for agenda. What we'll talk today. Today I'll quickly going through the quick overview of Ceph, then OpenStack and Ceph integration, then going with the few recommendations for the OpenStack and few recommendations for the Ceph, then followed by question and answers. So quickly tell before all my recommendations, this is a setup we are using it out. Typically we have a general purpose cloud with 200 nodes. We are using for compute, block storage and object storage as use cases. And currently we are running approximately 2500 VMs with 40 TB RAM and 5000 CPU cores. Everything is with a raw Ceph storage with 4 petabytes. On the average, we are using for 20 GB Linux volumes as a boot volumes and 200 GB Windows volumes. Sorry, 100 GB. So on the average, we are having the data volumes for 200 GB for both VMs, as well Linux as well as the Windows. So below are the compute and storage configuration. Just glance it out. These are all compute configuration. This is the storage configuration. Sorry. No. Okay. So now we'll talk about quick overview of Ceph. So what is Ceph and what is just one? I won't spend much time on this. Just have a glance on this so that what Ceph provides. Ceph is designed to provide the excellent performance and reliability and scalability, which is the Ceph was designed for that. It has basically 3 components: Rados Gateway and RBD and CephFS. So RBD we use for the OpenStack Cinder as like block storage as a backend with RBD, right? And Rados Gateway is the object storage which is backend with the Rados Gateway client, which supports only the APIs, REST APIs which are compatible with OpenStack Shift as well as the Amazon S3. Everything is based on the Rados on the Ceph cluster, which is so all this Rados will be giving the block storage and everything will be stored in the Rados. This object storage, which is Rados Gateway, which has the clients, support the client's REST gateway, and again everything comes here. So Ceph file storage still not production versions, still not using. So I won't talk much about it. Sorry. I'm just confused with this. Okay. Now I'll be talking about the OpenStack Ceph integration. What are the components on the OpenStack? What are the Ceph components? How do both talk to each other? This is a typical diagram. What is the OpenStack? So it has this Cinder, Glance, Nova, and other components. So we'll talk one by one. Cinder. Cinder is the OpenStack block storage services which supports the persistence block storage for the users, and it talks to the Rados gateway, RBD, Ceph RBD, then eventually it comes to everything here, Rados. So Glance is again image services which will provide the catalog for all the images what it has stored and everything. Again it backend by the RBD, all it stores in Ceph Rados. Similarly, I will first talk about Shift. Shift is object storage of OpenStack, and it has interface APIs which will talk to Rados gateway client and eventually store all the objects into the Rados. So coming to Nova. Nova is a compute services which will spawn VMs and manage VMs and attach volumes and all things using the hypervisors. So Nova talk to hypervisors, and all the backend is RBD. Again, all the volumes everything will be in RBD, and coming to the storage here. So here is a typical flow for the block storage and object storage. So first block storage, if we go here, the OpenStack Nova will be there. It will talk to the libvirt, right? So libvirt configuration will say that how to talk and what is the my RBD and all things. It will come to the QEMU, and from the libvirt, from the libRBD, from librados, this is the lower part where the OSDs and everything will be available, mons, OSDs and everything will be available. Similarly for the object storage. So object storage, it doesn't have anything like front end. It will depends on the S3 APIs compatible and Shift APIs compatible. User will talk to this API compatible. The request will come from here, go to the Rados gateway client. Again, Rados gateway client is built on the librados. Librados again internally goes to the Rados Ceph Rados. This is a typical flow for the object storage and block storage. So now I am going to talk about the few recommendations for the Ceph to get the best performance or the tunings. But these are all the recommendations based on my experience and what we have done. So again, it depends on the use case. It's not one-to-one mapping of all the use cases whatever we are using now. So first I'll talk about the Glance. So what is Glance? We just discussed about Glance. Glance is a OpenStack image services, right? It provides all the images and the catalog available for the images. So here I have few recommendations, like this is the first one, say default. If you want to use the Ceph as a backend, default or storage, you can need to say RBD, that is the default one. Second one, disable local caches. If you are using the boot from volume, your images, you are spawning a VM with boot from volume, you will download the image always and keep it in the local cache. Let us say if you are doing for 1000 times, 1000 VMs you are spawning, 1000 times the image will be downloaded and kept on the local cache, which will eventually kill the compute's local space, right? 10 GB into 1000, too big number, which will all space will be gone. Due to that, you may impact about the existing processes, lack of memory, lack of threads and all things. So I recommend to remove the local cache. So second one is a very important thing, which is like show the image direct URL and show the multiple locations. So this will support us to two ways. One, there is no downloads required if we have direct URL available, and no copy required, because due to that we know where the image is available. So here is an example with the direct URL. We could see the direct URL as like this: RBD, image ID, images. The full location will be like this. Else we need to go to the glance, ask for that, keep downloading, and keep it in local cache or don't keep it. So it has all the time saving for that. For the glance with Ceph, always I recommend use the raw images, because Ceph internally supports the raw images only. This helps to save the conversion time. So here are the sample test results what we have ran it out. If you use the QQ2 image of Windows, about 50 GB, booting time took around 45 minutes. So simple, if the raw image, so less than a minute, because it saves the time on conversion, downloads and everything. So quickly picks the image from the Ceph itself and boots. Okay, so now I'll talk about the Cinder recommendations. What is Cinder? Obviously we discussed, right? Cinder is a block storage services from the OpenStack, and it supports the persistent block storage things. So here I don't have much recommendations except one. So the default one, if you want to enable the Ceph as a backend, just say enable Ceph backend. And for the Cinder backups, I always recommend to use the Ceph if you are using the Ceph as a main storage. Backup also you should be having on Ceph, because Ceph internally supports the incremental backups. So once you have your backup is backend by Ceph, all your backups are incremental backups. That will eventually save you a lot of space. Let us say first backup is 10 gig, second backup is 12 gig. You will be having only 2 gig for that. And Ceph has well known about this support, so it maintains all the node dependency maintenance and everything it maintains. So this is a strong recommendation if you are going for the Cinder backups and with the Ceph as your main storage. It is recommended to go with the Cinder backup. This is a default configuration, nothing much, but I recommend this to go as to have the incremental backup to get a lot of space savings. So coming to the Nova I don't have much recommendations, except this is a default configuration to configure things, and I recommend to use the librados instead of KRBD. So librados will link with the libvirt configuration, where we need to say enable cache. That will give a read IOPS more, read performance will be more. Okay, so that's what the basic components of OpenStack recommendations. Now I'll go with the Ceph recommendations. We have a lot of things here. Major recommendations come from here only. Okay, before going for the recommendations, we need to answer the decision factors, right? Use cases. What is the storage required, right? And there are two types, right? We have a raw storage. Let us say I have so many petabytes of raw storage. Can I use everything at one shot? Because Ceph use the replication factor 2, 3, 4 based on the use case, right? We have 4 petabyte, 2 replication, we get usable as only 2 petabyte. If you have 3, divide by 3. So this is the again required, depends on the use case, depends on the requirements. Similarly, we need to decide on how many IOPS required. What is my requirement? I want very high IOPS with low cost, or see average aggregated how much, per VM how much. These are all we need to get answers before going for the tweakings and things. And again, most important thing is that what to optimize. We want to optimize for the performance or optimize for the cost. These are the very challenging item. Both are very opponents, right? See, if you want to optimize for performance, you need to put a lot of money for that. Or you want to cost for this, you need to compromise on performance. So this is again decision factors before going for any performance, any tweakings. So here is a quick performance optimization criteria. So I could simply, this a table is a self-explanatory, just glance it out. So what is IOPS? So low cost, high cost, and throughput is what is optimized, and capacity, what is the cost per TB? These are the examples. This I have given the examples. Okay. Now I'll be talking about OSD considerations. Ceph has OSDs, right? What is OSD? OSD is a object storage domain which is responsible for storing the objects to the file system. For this, I have a few recommendations, like what is the CPU required, right? This is the minimum, it's not maximum. So these are the minimum requirements for CPU, RAM, and all things. If you have more, it will be better. And Ceph Mons. Ceph Mons is a Ceph monitor daemon, which is the maintain the consistency about the maps of Ceph monitor maps across the cluster. This daemon maintains the consistency across the cluster. Again, it is recommended to use one Cephmon node for 15 to 20 OSD. So let us say we have more, it may take time to make the consistency, copy the maps one to other, delay may happen. And networks, always networks, right? So we should not cross the network throughput. What is the all OSDs? Let us say I have 20 OSDs which give some X throughput altogether, and we should have the at least X or above X. We should not below X. So that will throttle the performance, because all the OSDs operations will go and block at the network layer. So it is suggested, or at least should not exceed the network throughput. All OSDs. Again, threads. See, if you have using the more OSDs on a single node, each OSD will spawn lot of threads based on its internal operations like backfilling, right, recovery, scrubbing, lot of things, right, blah of things. But be careful that number of threads should not affect our performance. So Linux will support some X number of threads only, or Linux box. So always recommend at least around 20 should be recommended value for the OSDs. And one more thing here, for the Ceph OSDs, always go with the JBOD mode. Never go with any RAID setups. Because if you add the RAID one, it will eventually cause the RAID controller, all the performance bottlenecks comes. Because Ceph itself maintains the copies and all things. So definitely go with a JBOD mode, no RAID required. So now I'll be talking about Ceph OSD journaling. So what is journaling purpose? Why people use the journaling? So basically journal use it for getting the speed and consistency. Right? So Ceph OSD daemon will talk to the journaling to quickly write the data to the desks. Quick operations. And consistency, how it comes. OSD will take care to flush the data to OSD from journaling to the file system with a fraction of seconds. During that time, it won't do any write operations or read operations, but it flushes the data to the file system. So these two operations, OSD will help, the OSD journaling will help us to get the performance. Again, we have multiple types of journalings. On-disk journaling, or use the separate hard disk as a journaling, or we can use the SSD journalings. So if you use the SSD journaling, we will get good performance compared to the on-disk. So we have a test results which we have done with on-disk journaling and SSD journaling. With on-disk, we got around 45 Mbps. For SSD, we got almost double. But we have our test environment used with 1:11 SSD OSD ratio, but as the Ceph recommendations, this is a 1:4 or 1:5 or 1:6 is the better one to get the best performance. So same results we have done for the other things, sequential writes and random reads, sequential reads and random reads. These are the results for this. So operating system considerations. If you have a Ceph nodes or Ceph, what are the operating system tweaks we want to set it out? Just is all, you can just glance it out. Nothing, it's all self-explanatory. CPU tuning, IO scheduling, disable NUMOS, swappiness, right? Kernel, put the maximum kernel things, enable the bias with HD and VT. But these are all the not default things, but these are all required to improve the performance from the OS side. Okay. So now I'll be talking about the Ceph networking. So what are the things required for the Ceph side? So it is always recommended to use the two networks, one for the public or user, another for the cluster network. Because Ceph has doing a lot of internal activities like rebalancing, recovery, scrubbing, so many other things are happening. So these operations should not affect the public network. Let us say we have only one network, Ceph is occupied everything, so users will see the slowness of that. So that is the best one is to go with two networks, one for the public and one for the cluster. So if you have two NICs, so two networks comes with two NICs. So better to use the 10 gig if you are affordable to, or 1 gig is fine, but it is advisable to go with 10 gigs because Ceph is a lot of intensity using all the operations, internal operations. And one more point, jumbo frames are recommended across the network. So these are how to set the jumbo frames. And the Tor switch and spine switch, we need to have a high bandwidth and always go with the BMC hardware to get all the alerts and all things. So in our environment, we have done the NIC bonding. We have two NICs with a 10 gig and we have done that NIC bonding with the ALB mode, balanced ALB mode. So this is a before NIC bonding, we got around, this is speed average 5 Gbps. Now after doing the NIC bonding, we got almost 9 or 8.x Gbps. So I recommend to use the NIC bonding wherever possible to achieve the good performance. Okay. So now I'll be going for the failure domains. What is a failure domain? A failure domain always says that something fails, we cannot access our data. That is a failure domain. Ceph supports, these are the failure domains, starting with OSD, host, chassis, rack, ROP, PDU, POD and all things. But there is a info, right? So if you have something cost added for the isolation of data, if you go with the failure domain as a host, we should have that many hosts to support our environment. Again, similarly, if you have chassis, rack, again it will cost added for the cluster. For example, if you want to go for the rack, we should have minimum 3 racks or 2 racks as per the replication count. So I recommend based on this, right, you select the chassis or the rack for the failure domain, for the data durability and data availability. So now I will talk about operational recommendations. So what are the, during the Ceph is running, we want to tweak the performance, or we are impacted by so many items, how to deal those things. Few or the things are scrubbing and deep scrubbing. What is the scrubbing and deep scrubbing do that? Scrubbing and deep scrubbing is a mechanism to maintain the data integrity across the Ceph cluster. Scrubbing is simple light scrubbing. It will just check the object size as well as the attributes are fine. It won't do not more than that. But deep scrubbing will read every data and checks it, checksum, everything is fine. So this deep scrubbing will takes a lot of CPU cycles and impact the performance of the existing cluster. So we have, these are the options how to disable, enable the things. So once we disable, Ceph will go, health will go on state, and again we can enable like this. So this deep scrubbing, Ceph supports few options, like we will enable the scrubbing begin and end times. So let us say normally we have the operation, so non-peak times, users will be there in the 8 to 8 or something like that. So in that time, we'll stop the scrubbing. Ceph won't do anything scrubbing backend. So we will set timings, when it start, when it begins. So what is the threshold levels? And similarly for the deep scrubbing, these are my intervals. Like deep scrubbing, I can set it to 2 weeks once per PG. So that after 2 weeks only, it will again read all the objects and check it out. If it is everything perfect, then do that. And other performance, right, the related operational items comes like recovery and backfilling. So let us say we have some OSDs or some node gone down. There is a lot of objects do the backfilling and recovers. The data has to be recovered, right? So these are the parameters which will impact on these operations. Max backfill is a default is 10. Either you can increase or decrease, but there is a complexity on it. If you increase it out, performance, the recovery backfill goes fast, but if you decrease it out, it will go slow. So basically these operations are linked with the user operations, share the same bandwidth on user operations and the cluster operations. So these numbers we need to tweak very carefully during the what time we can do and when we don't want to do these things. And these are all things we can dynamically tweak, nothing to restart, nothing to do anything else. This Ceph commands tell we can inject the things dynamically and we can change that. But before, these are the very carefully taken, that may impact your user operations. If you increase, impacts the user operations. If you decrease, definitely it takes, recovery takes long time. Okay. So finally I have the few guidelines for the performance tuning. So always change one option at a time. Never play with two options at the same time and we don't know what's happening with other things. So always I recommend to play with one option at a time. Check what is changing. Let's say you have changed the X option and identify what's happening with that and see if it is impacting or not impacting or not. And if of the option related performance test you need to run. Let us say you have changed the IOPS related things and you are testing the performance of other things which are not related. So you cannot identify whether this tweak or performance tuning is really working for you or not working for you. So that is the reason, choose the right performance test for changed options. Reset changes at least 10 times. Don't assume that one time I have done, okay, it is working fine, okay, I'll go with this. Never do that. Do at least, I recommend 10. Maybe you can take bigger number or smaller number. It is always good to go with 10. See, oops, sorry, what happened? It is recommended to change multiple times and see what's happening and identify that, then only take a decision. And if during the any value or configuration changes, do you see any errors in the log files? Just observe that. So that will be very important. And look for the results of the things and estimate these general things. So coming to the Ceph tuning side, Ceph cluster parameter, that's what I already told that. So we can dynamically change the workloads or change the performance configurations dynamically. No need to do rebuild, do the restart service, nothing required. But these changes may impact the data integrity, and so that it may cause the rebalancing more and reduce the network bandwidth. Tuning should be performed on the only test environment. So this is the most important. People directly do on the production environments and see, oh, my production gone, what happened to do. So it is always recommended to do the testing of the tuning or testing everything on the test environment, and confirm that all the results are fine and everything okay, and make the automated process to how to do on the production, then go for production. Okay, so now time for question and answers. Yeah.
So, brief follow-up to what you were saying about, run the test a number of times over again.
Yeah, could you please come to the mic so that it is recording?
Oh, I see.
This side.
Over there. Oh, okay, sorry. So it's a brief follow-up to the statement about the testing and make sure that it's done a number of times. I have worked with disk testing in the past, and there is actually a group called SNIA which deals with being able to measure performance metrics on disks. And yeah, there are recommendations for the minimum number of times you need to rerun a test in order to be able to determine that's statistically valid.
Right.
There's also something very important to note on that one, and that is solid state disks, of course, perform better when they're new. So they have an elevated period of performance that will drop off after a certain period of time.
Yeah.
So I'm very glad to see that you put that on there and we're mentioning that, because that is a big pitfall. So it's more of a thank you for validating that than necessarily a question. So thank you very much.
Thank you very much.
Hey, very good talk. Just a quick question. So one of your slides mentioned that it's highly recommended to have hyperthreading enabled. So why is that? Did you do any benchmarks comparing Ceph performance with and without hyperthreading, or what's the motivation there?
High profiling.
So one of the slides further about the
Okay. Look, fine. I understand that. The BIOS settings I have recommended, right? Okay. See, nowadays, the BIOS comes with the default and disabling the hyperthreading and virtual technologies. But Ceph requires the lot of CPU cycles to perform the operations, because Ceph OSD, one OSD will do all sorts of actions like recovery, rebalancing, scrubbing, deep scrubbing. So much activities has required. Definitely, if you enable the hyperthreading, it will add the performance. And by default, nowadays all BIOSes are coming with disabling state. So I recommend to go to the BIOS settings and enable that.
All right, thanks.
Yeah, thank you.
The real reason you want hyperthreading is it kind of hides the latency of the memory accesses, and Ceph is all about going to storage.
Exactly.
So when one thread's going and doing something in storage, scrubbing, cleaning, whatever, or storing, the other thread can make progress.
Right. Thank you. That. We have left 4 minutes left. Any more?
I have a question about networking. This cluster networking should be separated physically, or should be another VLAN? Do you have any test results about this difference?
I don't have at the moment, but it is recommended to go with physical if you have the infrastructure supports. because going for physical is almost cost, right? We should have all TORs and we have routers and everything. But worst case, we can go separated with the VLAN, it should be okay.
Okay, because we have one network and we observe packet drops on our switch, and I'm thinking about separate this network physically to another switch, and I don't know if I see any difference or not.
There will be difference will be there, but again, right, depends on the use case, whether if you are able to provide all the TORs and right, then it's advisable to go with that.
Okay, thank you.
Okay.
Hello.
Yeah.
You mentioned that you recommend to use HBAs for connecting disk OSD devices and not recommend using RAID controllers. And did you run some tests or other things? Because our experience showed that RAID controllers with enabled cache gives better performance than HBA mode.
Okay. I didn't have that use case. Maybe later I'll talk to you and we'll give the information. Okay. Thank you. So last minute.
Does this Ceph cluster go to warn after it couldn't be scrapped for, I don't know, days or weeks if the load is too high?
Okay. It is not like that. It will be operation. If you disable the options, I have showed you, I'll go through that. Okay. So if we disable the options, then it will go on one state. So this is what I have disabled here. If you unset the scrub option, then it will go on one state. But due to the high load, it is not complete in the scrub, it won't go for that. Because eventually it will try to do that, right? So Ceph health will be okay. Any more? Thank you very much for the patience, your time. Thank you very much.